First, let's see what code reuse means. Code reuse is also called software reuse. This refers to building new software using existing software or software knowledge. Reusable software or software knowledge can also be viewed as reusable assets. These assets also include design, requirements specification, inspection, architecture, etc. The best-known reusable asset is source codes. Simply speaking, code reuse is the use of some or all of the programs written at some point in later development of other programs, and a typical technique that saves time and efforts in tedious work. The library is a good example of abstraction. Programmers normally create abstraction points internally to make parts of the program reusable, or create custom libraries for their own use. The features that make software easy to reuse are called modularity, low coupling, high cohesion, encapsulation, separation of concern. When you create new code using existing code, you must define some interface or access method. This typically involves subroutine calls, objects, classes, prototypes, etc. Companies typically formalize and standardize them. Developing the next version based on a previous version of a program can be seen the starting point as a kind of code reuse. By the way, in a form of code reuse, you may want to take some or all of the code from an existing program and copy it into a new program. This method is used by companies to speed up their development, but caution should be taken when copying and pasting a lot like this, which can be problematic with duplicate codes in the future. There have been many researches on programming techniques to make reuse quick and easy. Object-oriented programming was also created for this purpose, and it has become a representative reuse technique. For this purpose, there is generic programming. A new alternative is automatic programming. This is a technique in which a program is created based on a set of variables given by the user. A similar concept is metaprogramming. There are things to consider when applying reuse. Let's take a look at some of the key points to consider when trying to introduce software development methodologies using reuse, and what roles they play in terms of reuse. The first is a structured reuse-based software development process. Reuse can be intuitively considered very straightforward, but extreme care needs to be taken because it does not reuse for objects with tangible and physical characteristics. Because the software itself requires accuracy and speed, the components selected for reuse must be correctly integrated to the entire system. Therefore, the reuse-based software development process should be not arbitrary and randomly done, and it is likely to fail if the systematic and procedural approach is not applied. The software development process using the reuse method should be presented as a mechanism to consider reuse approach from identification and domain analysis of requirements. In particular, software development processes must consider reuse approach because software must be developed with interoperability with libraries that manage reusable components. The conceptual diagram of the interaction between the reuse-based software development process and the library is shown below. As shown in figure, one component of the reuse library can be seen to be associated with multiple interconnected artifacts. The structured procedures are required for interconnected components to be used in the system's development. Systematic reuse concepts and processes has been established software product line engineering methodology. Therefore, it has a positive impact on many companies which are concerning the productivity and quality. Second, it is the establishment of a system for building a reuse culture. Introducing reuse into the software development process requires a shift in awareness and culture to the development department. This requires developers to change their minds and requires to build a culture of organizational and institutional aspects. In order to establish such a system, the following must be put into practice. Our reuse management organization is needed to set up a reuse-based software development approach. These management organizations introduce and enforce reuse-related procedures and standards. They also enact and implement policies to increase reusability. And the reuse training should be regularly conducted to increase the reuse mood within the organization. These trainings should be conducted not only for the developers, but also for the project's managers and organizational managers. In terms of curriculum and content, separate training is required for administrators and developers. And take a systematic approach to increase the reusability in the early days of reuse, since organizations may find it very uncomfortable. A typical example is the introduction of an incentive system for reuse. In addition, the organization helps developers change their mindset by securing reliability of reusable components. At the same time, there must be sufficient reliability assurance for managed components in the reuse library, and there should be approaches to find the right component. Third, it is necessary to establish a reuse environment through initial investment. In order to support reuse in the same context as mentioned above, environmental factors must be provided for reuse. An environment that supports reuse is a system that builds a library system that maintains reusable components, and a tool that supports functions such as search and modification in conjunction with a library system, and a communication network required to support reuse at local or remote locations. Fourth, continuous library improvement and upgrades are required. The emergence of a new programming language, the development of new systems, and the development of new software components through new user requirements have continuously been happened. Also, the reusability and usability of the library are degraded if problems identified by the developer during the reuse process are not fed back to the library and the problem is not recognized by the library. Therefore, developers should collect the problems occurred during the reuse process, improve the library and search tool, and continuously register the newly created reusable components as well. Fifth, it is the reuse with the support of the tool. Even if the process for reuse has been established, it would be very troublesome if it had to be done by hand. So it is necessary to have a tool that supports reuse. These support tools are shown on the screen. They are Component Browser, Debugger, Text Editor, Compiler, Test Supporting Tool, Email, and other tools. These tools are linked to library management tools for reuse and exchange data with each other so that reusability can be improved. Library management tools for reusable components require functions such as component registration, modification, and deletion, and authentication for component reusability verification, mailing, library reconfiguration, and new domain creation. And it is necessary to have user functions such as a keyword or graphical component browser, a text editor, and a test supporting tool. Of these, compilers and debuggers are required due to the dependency of the specific language of the reusable component. The debugger can be used when integration and modification is required. These tools are best served in the form of possible integrated tools. In other words, it is necessary to construct interfaces between the tools so that human intervention is minimized as possible, so that they can be interconnected. Sixth, it is software productivity assessments and measures. A reusable software component can be evaluated for its productivity because its usability has already been certified and its functionality and size are known. Of course, it is a very easy development activity compared to software developed from the beginning, which there are no reusable components, and thus we cannot give equal measure of productivity. However, the number of reuse modules and the reuse rate can be used as a measure of productivity. Seventh, it is the management of a set of information about reusable components. The outcomes of software reuse can be domain information, requirements analysis information, design, source codes, documents, test procedures, test cases, and so on. This information is registered and managed in the library. In addition, it requires a component template that identifies and manages components. This template is assigned for each component and contains information about the development artifacts related to the component. Generally, types of reuse classification are as follows. They are architecture, source code, data, designs, documents, estimates, human interfaces, plans, requirements, and test cases. For example, if a reusable component for a communication protocol exists in a library, the existence information for that component must be linked to each other. Specification and analysis documents of protocols, source code that implements protocol, and testing materials can be managed by the identifier of component. The artifacts of each steps also have their own identifiers, which should enable hypertext-based searches. When it exists in the form of this information set, reusability is improved, and the library manager must be able to provide this set of information for new components that are registered for reuse. Finally, it is composition-based, component-based development model. If you are developing software based on reuse, you will use top-down and bottom-up development approaches together. The system is decomposed by defining the domain information for the entire system as the highest level of abstraction. The decomposition of these systems should allow for natural system decomposition without loss of overall operational concept for the system. In this decomposition process, we find the reusable components, and the decomposition to the system is done to the lowest level. Then we build a new system by combining reusable components with components to be developed. Developing systems in this way can be a very common and useful way. Let's continue to see what refactoring is. Refactoring is to make the software easier to understand by changing the internal structure without changing the visible behavior, so that the software is easier to understand and less expensive to modify. This is different from performance optimization. Let's look at the reason for refactoring specifically. First, it improves the software design. Refactoring can be accomplished for short-term purposes and maintain the design of the entire code by rearranging the modified code without considering the overall design. For example, removing redundant codes has the advantage of reducing the time it takes to modify the code, and the fact that source codes to be modified is in one place is a prerequisite for good design. Second, refactoring makes your code more readable by making it easier to understand. This makes debugging easier by making your code more readable. The benefits of design, readability, and debugging also helps not only quality, but also program productivity. So, when should we do refactoring? It's better to keep it going rather than setting the time. Mainly, it has happened when repeat similar work at third time according to the strikes rules. When adding new features to your code is long, slow, tedious, and tiring. It also happens when you change the design of a form that is not easy to add. It is performed when you need to fix a bug, and code reviews. Finally, when pair programming and extreme programming, refactoring is performed. First, let's look at what is code modularity. The modularity of code can be attributed to the basic principle of the algorithm: divide and conquer. It is not easy to apply it in practice. In theory, it's good, but the theory is not exactly applied when you're actually working, but you should be able to write code that fits these theories through your own codes. Let's look at the generic principles for code modularity. First, we find the common parts of the code and modularize them. This is one of the most common principles, and of course it seems to be a matter for developers. But when you look at the actual code, there are a lot of duplicates. The first is caused by the wrong design, or sometimes mistakes in the overly demanding requirements. The second can be seen as not doing some kind of refactoring. As you can see, code that is already woven cannot be perfect, so code refactoring will find the common areas and proceed for modularity. The following is the application of the design pattern. The design pattern can be a summarized set of commonly used or frequently used principles for experts to proceed with development. Therefore, most of the application of design patterns plays a very important role in refactoring or modularity. In real life, you will have to develop the ability to apply patterns that fit your project among various design patterns. The following is an analysis of well-structured code. Well-structured code modularizes common parts and applies appropriate design patterns to provide the right code. Pet Store, previously presented blueprint by Sun Microsystems at JavaSide, has not only a well-crafted source codes, but also it has been developed in a form suitable for each framework by repeatedly reconstructing various frameworks for specific needs. So of course, well-structured code that has been evolved is a good place to analyze and follow it. The following is an appropriate analysis of development work. Since the proper analysis of work is directly linked to design and implementation, it is essential that the analysis of the work that is designed and implemented should be made clearer because the analysis of the work is not the same as the example codes that are already analyzed. Finally, the utility code or data structure code is used appropriately. People who have been developing for a long time can be seen that they have their own utility code. For example, they are codes for encoding, decoding, byte util, and data structure implementation. In Java, many of these data structures are implemented in the collection objects, and in addition to these codes, you need to have the codes that suits you. Now, I will explain the code smell analysis and major refactoring techniques. Refactoring is a technique that improves the quality of software by changing the code style without changing the operating state by removing code smells such as low readability or duplicated logic of code. And the code smell is usually caused by the following reasons. This is usually caused by programs with low readability of the code, programs with redundant logic, and programs containing complex conditional statements. From now on, I will explain the types of code smell and major refactoring techniques to solve them. First, it is the duplicate code. The simplest case of duplicate code is when you have the same code in two different methods of a class. This can be addressed with extract method. And if the same code appears in two subclasses with the same superclass, you can use the extract method on both classes and then use the pullup method. Second, it is the long method. To make code with shorter methods easier to understand, you need to name them well. We write a method instead whenever you need to annotate something. In most cases, the extract method is used to reduce the length of a method. Decompose conditional is used when method extraction in conditional statements and loops may be required. The third, it is a huge class. When one class is trying to do too much, there are many instance variables in place, and thus there is a high probability that duplicate code will exist. You can use extract class to bundle many variables. You can select variables that are meaningful to each other in the class. For example, deposit amount and deposit currency should all belong together in one class. Fourth, it is the long parameter list. As a long list of parameters is hard to understand, inconsistent, or difficult to use, and constantly refine it whenever other data is needed, the parameter list should be short. You only need to call methods several times to get new data, so most changes are lost by passing the object. If the parameter list is too long or changes frequently, you may need to think about the dependency structure again. Fifth, it is the divergent change. It causes when a class changes frequently in different ways due to different reasons. If you look at a class and whenever adding a new database, you must always modify these 3 methods, or you have to change these 4 methods each time you have a new note, it is better to create 2 objects rather than 1. Sixth, it is the shotgun operation. Shotgun surgery is similar to divergent change, but it is the opposite. If you have to modify a lot of classes with little changes every time you make changes, you will have a smell of shotgun surgery. If things need to be changed everywhere, it's hard to find, and it's easy to miss important things to change. Seventh, it is the feature envy. The most common envy is greed for data. There are many times when you call multiple get methods on another object to compute a value. The method obviously wants to be somewhere else, so the move method is used. Sometimes only a specific part of the method suffers from this envy, so use the extract method for the envy part and then use the move method to move it to the proper location. Eighth, it is a data clump. A bunch of data coming together should be created as objects of their own. The first step is to find where the clump appear in the field. Use the extract class for these fields to turn this clump into an object. Then you can simply turn the interest into a method signature and use the introduce parameter object or the preserve whole object to simplify the parameter list. Ninth, it is the primitive obsession. The person to firstly interact with an object is reluctant to use the money class, which usually bundles numbers and monetary units, the range class, which has upper and lower bounds, and a small object for a small task, such as the class for special strings, for example, phone number or postcode. 10th, it is switch statement. The problem with the switch statement is that it is inherently redundant. Polymorphism among object-oriented concepts provides a great way to address this problem. When you look at the switch statement, you always have to think about polymorphism. If there are a few cases that affect only one method, you do not have to change them. 11th, it is a parallel inheritance hierarchies. This is a special case of shotgun surgery. In this case, if you create a subclass of one class, you have to create all subclasses somewhere else. You can recognize this smell if the prefix of the class name is the same as the prefix of the name of the other inheriting class in one inheritance structure. A common strategy for removing duplicates is to make instances of one inheritance structure refer to instances of the other. 12th, it is the lazy class. Every time you create a class, it costs money to maintain and understand it. Classes that do not do enough to cover this cost should be deleted. These classes were initially worth it, but they have been reduced in size as a result of refactoring, or they may have been added to reflect planned changes. 13th, it is speculative generality. It can be smelled when it is left to handle something do not need, saying, I think someday I need the ability to handle this kind of thing. As a result, the code becomes more difficult to understand and more difficult to maintain. This speculative generality can be found when a method or class is used only in a test case. If any of these methods or classes are found, you should remove them as well as the test cases that use them. 14th, it is a temporary field. Sometimes instance variables with an object are set only in certain situations. These temporary fields are common when complex algorithms require multiple variables. In this case, you can use the extract class by grouping the necessary variables and methods. The new object becomes a method object. 15th, it is the message chains. Clients can see the message chain when they ask another object to get an object. Another object asks again for another object. The object again asks for another object and repeats them. This progression means that the client is associated with the class structure. If any relationship in the middle changes, the client code must be also changed. In this case, you can use the hide delegate.